To conclude the chapter on trigonometry, let us now take a look at the inverse trigonometric functions. Since trigonometric functions are periodic, it means they are not one-to-one. So if we take, for example, a look at sine of x, we see that different input values, so different values of x, will give us the same y value, the same sine value. So all these points, they have the same y value. So this means that we cannot determine a unique inverse. Therefore, we will have to restrict the domain in such a way that the inverse will become unique. We will apply the following convention. For sine x, we will use the restriction that x is between minus pi over 2 and pi over 2. So similar as before, we are looking in the quadrants 1 and 4, because these cover all the possible outcomes of sine x. As you can see on the drawing, if we now have a y value, the input associated with it is unique. Let us denote the inverse by sine minus 1. Sine minus 1, also sometimes called the arc sine, or the inverse sine function. So basically this means that y is equal to sine of x if and only if x is sine minus 1 of y and x is limited between minus pi over 2 and pi over 2. Given these restrictions, you also have the cancellation identities. Meaning that the inverse sine of x is x, or sine of the inverse sine of y is y. Given here that x is between minus pi over 2 and pi over 2, or that y is between minus 1 and 1. The restriction for tangent of x is that x is between minus pi over 2 and pi over 2, but with the exclusion of minus pi over 2 and pi over 2. So again, we are looking in the quadrants 1 and 4, as we did before with the tangent, but because the tangent value of pi over 2 and minus pi over 2 does not exist, these two values are excluded. So also here, when we take a look at the image, you see that for the restriction, for every x value, there is one y value. For every y value, there is exactly one x value. So we have defined a unique inverse with this restriction. With this restriction, we have again that the tangent minus 1 of tangent of x is x if x is between minus pi over 2 and pi over 2, or that the tangent of tangent minus 1y is equal to y for y between minus infinity and plus infinity. For the cosine, we can do a similar reasoning as with the sine, only now we will limit it between 0 and pi. Similar thing as we saw before. If we look in the quadrants 1 and 2, then we cover all the options of the cosine. So also here we have done cosine minus 1 of cosine x is x, for x between 0 and pi, or cosine of cosine minus 1 of y is y, if y is between minus 1 and 1. Another option would be to define the inverse cosine through the inverse sine. So if you know that x is cosine minus 1y, then you also know that y is cosine of x, which is also the sine of pi over 2 minus x. If we then invert, then you get that sine minus 1 of y is sine minus 1 of sine pi over 2 minus x, which is just pi over 2 minus x. And since x is cosine minus 1, this is also pi over 2 minus cosine minus 1 of y. Rewriting then shows us that cosine minus 1 of y is pi over 2 minus sine minus 1 of y. In this case, we know that sine minus 1 of y is between minus pi over 2 and pi over 2. And as if we have pi over 2 minus these values, this will be between 0 and pi. And the one that we are missing then, the cotangent. So cotangent, this one will be defined through the tangent, knowing that cotangent minus 1 of y is tangent minus 1 of 1 divided by y. One very important remark, and a mistake that's often made: sine minus 1 of y is not the same as 1 divided by sine y. Sine minus 1 of y is the inverse function of the sine, so it is not 1 divided by the sine. Let's illustrate these concepts through examples. So for the first one, calculate cotangent minus 1 of minus square root of 3. We just saw that we pass this through the tangent minus 1, so it's tangent minus 1 of 1 over square root of 3 with a minus sign. Since this is a negative value, and the tangent minus 1 was restricted in quadrant 1 and quadrant 4, we know that the angle will be in quadrant 4. So the angle that we are getting here will be minus pi over 6. Second one, calculate the tangent of tan minus 1 of 10. This one is extremely simple. If you look at the drawing for tangent, then you see that once you move back, so you go from 10, you move back to tan minus 1 over 10, arriving at the axis, and then you take the tangent again, you go back to 10. So the answer is just 10. It becomes more interesting if we mix the trigonometric functions. So for example, calculate the tangent of sine minus 1 of 2/3. To solve this, set theta equal to sine minus 1 of 2/3. So we know that the inverse sine is an angle theta. And thus sine of theta is equal to 2/3. We can then plot this again in a right angle triangle. If this is the angle theta, we know the sine is 2 over 3, so it is the opposite divided by the hypotenuse. So these sides are 2 and 3. Our problem now has become find the tangent of theta. To find the tangent of theta, we also need the adjacent side. A simple calculation tells us that the adjacent side is square root of 5. Since the triangle does not give us information about the sign of the functions, we have to make a deduction. Here we see that theta is sine minus 1 of 2/3. So my y value is 2/3, so it will be in quadrant 1. Because of the restriction that we look for sine minus 1 with an angle in quadrant 1 or quadrant 4, we have a positive value of y, so we are looking in quadrant 1. Quadrant 1 also means that my tangent needs to be positive. And so my tangent here is just the opposite side divided by the adjacent side, so it's 2 divided by the square root of 5 with a positive sign. For the next one, calculate the cosecant of cos minus 1 of 3 over 5. Again, follow the same reasoning. Set theta equal to cosine minus 1 of 3 over 5. So cosine of theta is 3 over 5. If we draw this in the triangle, so this one will be theta. Cosine is the adjacent divided by the hypotenuse, so these values are known. Then the missing side here will be 4. To look at the sine, we know here 3 over 5 is in the first quadrant, so it's positive. So the angle will be in quadrant 1. And we know that in quadrant 1, the cosecant, which is nothing else than 1 divided by the sine, is positive. The solution thus is here cosecant of theta is 1 divided by sine of theta. And for sine of theta, we just look in the triangle. Sine is the opposite, 4 divided by hypotenuse over 5. So the final result is 5 divided by 4. What if you now have to calculate sine minus 1 of sine 7 pi divided by 3? Since 7 pi over 3 is not in the restricted domain, we first have to bring this one back to the restricted domain. So 7 pi over 3 is 2 pi plus pi over 3. So it's sine minus 1 of sine of pi over 3. And then they cancel each other out. We just get pi divided by 3. For the final example, calculate the cosine of tangent minus 1 of 2 plus tangent minus 1 of 3. In this case, let us first look at the inverse functions separately. So set alpha equal to tangent minus 1 of 2, set beta equal to tangent minus 1 of 3. Then you know that tangent of alpha is 2, and you know that the tangent of beta is 3. Furthermore, if we look at the angles, we see here we have tangent minus 1 over 2. So 2 is positive, which means that my alpha will be in the first quadrant. So alpha will be between 0 and pi over 2, with pi over 2 not included. Same reasoning for beta, tangent minus 1 over 3, we have a positive value. Beta is in the first quadrant, so beta will be between 0 and pi over 2. What we now have here is the cosine of alpha plus beta. So we need to know something about alpha plus beta. If we look at the restrictions for alpha and beta separately, then we can see that alpha plus beta will be between 0 and pi. Also, we know that the tangent of alpha plus beta is the tangent of alpha plus the tangent of beta divided by 1 minus tangent alpha times tangent beta. So this is the tangent of alpha is 2 plus 3 divided by 1 minus 2 times 3. So it is 5 divided by minus 5 is minus 1. Thus, these two combined tell us that alpha plus beta is either in quadrant 1 or in quadrant 2. And we know that the tangent of alpha and beta is negative. So because my tangent is negative, we know that the angle alpha plus beta has to be in the second quadrant. So in the second quadrant, we also know that cosine of alpha plus beta will be negative. The only thing we then still need is the value of the cosine. So for this we take again the triangle. We take a right angle triangle. We know the tangent is minus 1. In a triangle we only have positive sides, so we have a tangent of 1 in absolute value. So if this is my angle alpha plus beta, how to get 1? Tangent is the opposite divided by the adjacent. So let's say this is 1 and 1. Then the hypotenuse is the square root of 2. And thus the cosine of alpha plus beta is the adjacent one divided by the hypotenuse, but with a negative sign because we know that the cosine had to be negative. So it's minus 1 divided by the square root of 2.